Hey guys, another Chapter 7 video here for you. We're going to call this section 7.8, and we are going to work on how can I factor completely. So this is kind of the last stage of factoring for us. We've looked at how to do rectangle and diamond, and we've looked at special cases. Now we're going to get into one final step that I think is really important, and that's called factoring completely. Have you noticed, I don't know if you've noticed in class yet, but have you noticed that sometimes when we factor, there's multiple right answers? So like maybe you and another student both solve and you get two different answers, but I tell you like, hey, they're both actually right. Well, we need a way to eliminate that. It'd be nice to like guarantee that we all get the same answer. So let me show you how we do that today. Here is our example. We're going to factor 3n squared plus 9n plus 6. Now I happen to know for a fact that when you factor this one and you do your rectangle diamond, that there's more than one right answer. So we need to get into how can we all factor it the same? Well, how do I know that there's more than one right answer? Well, I see a common factor. Today we are going to go through some steps. The first step of all factor problems is we should look to see if we can pull out anything in common, any common factor. Now the reason I say there's a common factor is because 3, 9, and 6 all are divisible by what number? They're all divisible by 3. So here's what we're going to do before we even touch the rectangle diamond. We are going to divide each ABC from the quadratic standard form by 3. We're going to pull the 3 out of this problem. Now by dividing by 3, here's what we get. N squared plus 3n plus 2. 3 divided by 3 is 1, so that's a 1n squared. 9 divided by 3 is 3, so that's a 3n, and 6 divided by 3 is 2. Now, the 3 that we divided out can't just magically disappear. It's got to go somewhere. So what we do is we put a big parenthesis around it, and we put the 3 way out in front of the problem, and then we just leave it there. Now what we're going to do is we're going to factor and do our rectangle diamond with just the n squared plus 3n plus 2, just the part that we've pulled the 3 out of. So in our rectangle, we're going to put n squared and we're going to put 2. We're going to set up our diamond and we're going to do n squared times 2 is 2n squared. The bottom of the diamond is going to be that 3n. That's what goes in the bottom of our diamond. Now what multiplies to 2 and adds to 3? 2 times 1. Yeah, 2n times 1n. So we're going to put 2n and 1n in our boxes and then quickly do our rectangle that we're good at. So n times n is n squared. We know that. Bring the n down, we're going to need a 1n, so we're going to times it by 1. Bring the 1 over, we're going to times it by 2 to get 2. And there it is, n plus 1 and n plus 2. But watch this. When I go to write my answer, here's what I'm going to do. I'm going to write equals n plus 1 and n plus 2. But I'm forgetting something. What did we pull out at the very beginning that we just kind of ignored for the whole time? We pulled out a 3. So we have to put that 3 in front. 3 parentheses n plus 1, n plus 2. That's got to be where we place the 3. We cannot forget about it completely. It's got to be out in front. And then we've got our product. So we've got our sum, we've got our product, we've got our answer. So not every single factor problem has something that you can pull out. You have to look and decide if it's one of those problems or not. You have to make that decision. If all terms have a common factor, then what happens is there can be more than one right answer when you're factoring the rectangle and diamond. So this is a way to guarantee we don't get that. So let's look at 3 questions here. We're going to label ABC. The first one is this. 12x squared minus 10x plus 2. Now, we're not going to do the rectangle diamond right now. I just want you to look at it and decide, can I divide anything out of this problem? Or is it ready to go straight to the rectangle diamond? Well, let's see. Couldn't I divide by 2? Wouldn't 2 divide each of these pretty evenly? So that would leave me with a 2 in front. And 12 divided by 2 is 6x squared. And 10 divided by 2 is 5x. And 2 divided by 2 is 1. So now I'd be ready to go do my rectangle diamond. Okay, how about this one? 10x to the 3rd power plus 25x squared minus 15x. Anything divisible on this one that we could pull out? I'm going to guess that you're saying 5, that you could divide by 5. Absolutely, but there's actually something else. I kind of threw something new in here. There's something else we can divide out. What's different in this problem compared to like all the other problems we've done? How about that x to the third power? We haven't been doing those. We've only been doing quadratics, x squared. Why don't we divide an x out of this problem? Look, everything has an x. We could take away one x from every single one of those terms. So the 5x would be in front because that's what we're dividing out. 10 divided by 5 would give me a 2, but it'd be 2x squared because x to the third take away an x. And then x squared take away an x. And then x divided by x would just be 1. So look, we're going to get this. 2x squared plus 5x minus 3. 2x squared plus 5x minus 3. Okay, last problem, letter C. What can we divide out of 3x squared y plus 2xy plus y? Well, we definitely can't divide any numbers out. Like 3, 2, and 1 don't really have a common factor. But I did notice that there's a y with each of these terms. So why don't we divide the y away from each of these and pull it out? That means we have y out in front, and then we have 3x squared, 2x, and then power of 1. 3x squared plus 2x plus 1. So there can be lots of different common factors. It can be a number, it can be a variable. Whatever you can divide out goes in front of the parentheses. All right, let's look at another example. Example 2 here. We are going to factor 5x squared plus 15x minus 20. Step 1 is to pull out anything in common if possible. It's not always possible. But this one is, what can we divide out of this problem? We can divide by 5. We're going to divide by 5 on each of these, which means we're going to have a 5 in front of a parenthesis. And what's left over? Well, we're going to have an x squared, a 3x, and a minus 4. 15 divided by 5 is 3. 20 divided by 5 is 4. So we just got to simplify this down. And then step 2, when we go to do our rectangle, is we're only using the x squared plus 3x minus 4. Forget about the 5. It's out of the problem for now. So set up your rectangle. Put your x squared and your minus 4 in. Set up your diamond. Times the rectangle corners together. So x squared times negative 4 is a negative 4x squared. What will go in the bottom of our diamond? What will be in the bottom? Yeah, that 3x. That's what goes in the bottom of our diamond. So we'll put the 3x down there, and then we got to multiply to negative 4, but add to 3. Not a lot of things multiply to 4. 2 times 2 and 4 times 1. So to make it work, we'll have to do 4 and a negative 1. That means we'd get 3. So 4x and negative 1x, and that goes in our boxes. And then we just do the outside of our rectangle. So we can do that pretty quickly. X times x is x squared. If we bring that x down, we'll have to times it by negative 1 to get negative 1x. If we bring the negative 1 across, we'll have to times it by 4 to get negative 4. And I think we've got our parentheses, x minus 1 and x plus 4. All right, so final answer, I'm going to write equals 5 parentheses x minus 1 and x plus 4. And put that 5 back in front, and then we have our sum, and we have our product, and we have our answer. We factored. Okay, let's do example 3 and look at another one here. Here's an interesting special case. We are going to factor 2x cubed minus 50x. 2x cubed minus 50x. Why is this a special case? Well, first off, out of the ABCs, we're missing one of them, so that makes it a special case. We also can do a pull out. We can divide by 2 on both of these. But what else can we take away from this problem? An x. We can take an x from both of these. So we're going to divide out the common factor of 2x. That means 2x goes in front of the parentheses. And then what's going to be left inside? Well, let's see. X cubed, take away an x, makes it x squared. 50 divided by 2 is 25. And then the x, take away the x, is gone. So x squared minus 25. That's what we're left with. But I'm going to rewrite that. I'm going to write that as x squared plus 0x minus 25. That way I have my ABCs for my rectangle. So put that 0x in the middle and let's solve. X squared goes in the corner, negative 25 goes across from it. Then we're going to set up our diamond. And when we set up our diamond, we are going to be multiplying x squared times negative 25. And that'll be the top of our diamond, which is negative 25x squared. On the bottom of the diamond, what would we put in the bottom? We're going to put that problem child, that 0x, that piece that was kind of missing. So we're going to put that at the bottom. And then we're going to multiply to 25, negative 25, but add up to 0. Thinking 5 times 5, but we'll have to do a 5x and a negative 5x to get that 0. So 5x and negative 5x go in the boxes, and then we quickly go around the outside of the rectangle. X times x is x squared. We bring that x down. We're going to have to times that x by negative 5 to get negative 5x. We bring the negative 5 across, and we're going to have to times it by 5 to get 25, negative 25. So we can see our parentheses, x minus 5 and x plus 5. But when we go to write our answer, we're going to write that 2x in front. 2x times x minus 5, x plus 5. That's our sum and our product. So I'm going to label it sum and product. Alright guys, before we end this video, let's see if you've got the hang of this. So I'm going to give you a you-try problem, and I'd like you to try to factor this special case, 3x cubed minus 6x squared minus 45x. This is your turn to see if you got a handle on this. So hit the pause button on your device, give this your best shot, and when you are ready, unpause your device and check your answer. Good luck. Okay, you ready to check your answer? Have you finished the problem? This one's definitely a special case because what can you pull out? Well, you can divide a 3 and an x away from each of these. A 3x can be divided on all of them. So we're going to be left with a 3x out in front, and we're going to have x squared minus 2x minus 15. That's what we're going to do our rectangle diamond with. So you've already done this, so you're checking your answer, so I'm kind of going faster through the steps here. But your x squared and your negative 15 went in the corner, and you got negative 15x squared. To solve the diamond, you're going to have to do 3x times negative 5x. On the outside edges, you're going to have x times x, you're going to have x times 3, and then the negative 5. So your answer is 3x times x plus 3 and x minus 5. I'm going to label this sum and product, and you should see, how did you do? Did you get the same thing? You might need to pause the video and kind of look the screen over since I flew through this one pretty quickly. But really, it all comes down to, did you pull out the 3x at the very beginning? Because that kind of makes or breaks if you can do this problem. Alright, so let's wrap up this video. So factoring completely, what does it take? Well, you got to divide out a common factor. This will guarantee all people, everyone who's doing the problem gets the same product answer. But remember, there's not always a common factor. All the examples we did in this video had common factors, but many of the examples we've done in earlier videos did not. So you got to look for that. You have to decide, is it a common factor problem or is it not? Thanks for watching, guys. I promise we'll practice in class, and have a great day.